Hi everyone, welcome to Homework Help with me, Mr. C. Let's get started. Number one, from Hartford to Los Angeles is 2,895 miles. So that's Hartford, Connecticut, 2,895 miles. From Hartford to Portland is 3,020 miles, 26 miles. The distance from Hartford to Portland is how much greater than the distance from Hartford to Los Angeles. So, since we're dealing with the how much greater problem, we have to take the larger amount and then subtract the smaller amount to find our difference for the two. Number two, we have how ordered 15 boxes of microprocessors. If each box contained 24 microprocessors, how many did he order in total? So we have a number of groups times the number in each group equals the total. For this one, it looks like if you order the 15 boxes, that's the 15 would be the number in each number of groups. And there's 24 in each, which 24 is 2 times 12, which is just 24. And once you multiply those, you'll find your total. For A, if the diameter of a wheel is 1 yard, so if we have a circle shape, and the diameter is 1 yard across, then the radius is how many inches? So what we have to take from this is that the diameter is a whole yard. So then the radius is going to be half of the yard because radius is always half of the diameter. So you need to turn yards into inches using conversion and then take half of that amount to find the radius. Write a statement telling you how you know your solution to A is correct. So you just give me a complete sentence on how you believe A is correct. 6, how many 1/8 are in 1? So what we have here is the reciprocal that we're taking of 1/8. So we take the reciprocal to find out how many 1/8 are in 1. And how many 1/8 are in 3? So for this one, again, it's slightly different because you have 3 total wholes, all of them split into 8 parts, or 8s. So that's half, it's 4. Well, you get the idea, right? That there's 8 1/8s. Wow, I messed that up. Okay. That there's 8 1/8s in each of these. So then you have to count the total amount of 8 1/8s that you have. That's like saying how many slices of pizza are in 3 large pizzas. Write the reciprocal of 3. Remember that for whole numbers, it's 3 to 1. Then you flip it. What fraction of 3 is 1? So what fraction of 3? 3 would be the denominator, and 1 becomes the numerator. Use prime factorization to reduce 540 over 600. So you want to find the prime factorization of each of these first, and then 600. You can use your factor tree for this. I'm going to get you guys started though. So let's go with 54 times 10, and then 60 times 10. Just remember that you're going to factor it all the way, and then you're going to eliminate the common prime factors and then simplify. What is the greatest common factor of 540 and 600? So from there, you just need to find the prime factorization of 540 and of 600. Once you've done that, you're able to find all the common prime factors and multiply them. For example, if you wanted to find the greatest common factor of, let's say, 10 and 20, you need the prime factorization of each. So for 10, you have 5 times 2, and then for 20, you have 5 times 2 times 2. You'll notice that they have a 5 in common and they have a 2 in common. So we just take one of those each. So the greatest common factor would be 10 using prime factorization. All right, number 9. What type of angle is formed by the hands of a clock at 2 o'clock? So you're going to need to make a circle. I'm trying to make 3 circles. I know they're not perfect, but let's pretend they are. For 2 o'clock, it's pointing at noon. All of these are actually pointing at noon. And then we have 2. We have 3. And we have 4. And so what we're looking at is what type of angle. We don't actually need to take the angle measurement. We just need to find out what kind of angle it is. So it could be acute, straight, right, or obtuse. Describe how to complete this equivalent fraction. Well, we just have to multiply the numerator and the denominator by the equal factor. That'll get us the 30. Name the property we use to find equivalent fractions. Well, we're basically multiplying by 1, which makes that the multiplicative identity property. The prime factorization of 1000 using exponents is 2 to the power 3 times 5 to the power 3. Write the prime factorization of 10,000 using exponents. So we need to multiply by another 10, which is basically multiplying by another 2 and another 5. So that would become 2 to the power 4 and 5 to the power 4. Write the prime factorization of 10,000 using exponents. So we can basically say it's 100. And then you have to find the prime factorization of 100 to find the using the exponent answers. Draw 2 parallel lines for 7 that are intersected by a third line perpendicular to our parallel line. So we have 2 lines that are parallel, and then we have a third line that's perpendicular. What type of angles are formed, and then you just look at the type of angles that we know about, and you'll see what type of angles are being formed. The perimeter of a square is 1 yard, so we have a square. If the perimeter is 1 yard, then that means all the way around is 36 inches. So if we want to find out how long each side of the square is, we just need to divide by 4 since squares are regular polygons. What is the area of the square in square inches? Well, you take the side of the square and multiply it by another side to find the square inch area. Number 14, this equation illustrates which property does not apply to division. So we changed the order, but we don't have the same answer. The commutative property tells us when we change the order, but we don't change changing the order. In this instance, though, changing the order does change the answer, so it doesn't apply for division, only for addition or multiplication. The front and back covers of a closed book represent 2 planes that are what? So if you look at a book that's closed, you have the front, the cover, and they actually don't ever really touch. So because they don't touch, they're going to represent a specific type. It's not going to be intersecting or perpendicular. 16, write and solve a word problem about equal groups that fits these equations. So 12 of something, each of them a certain price. You'd pay a total of $3.36. So you're buying 12 cookies, you're selling 12 movie tickets, you buy 12 packs of a pack of baseball cards. That has 12 cards in it. However you want to make it. 17. So we have 4 and 7 12 equals x plus 1 and 1 12. Since we're adding to the x, we need to use inverse operations. So we're going to subtract 1 and 1 12 from both sides. Keeping that in mind that we're operating on the fractions and we're operating on the whole numbers. For number 18, w minus 3 and 3/4 equals 2 and 3/4. Again, the inverse operations tells us that instead of subtracting, we're going to add 3 and 3/4 to both sides. For number 19, we have 10 to the power of 5 divided by 10 to the power of 2. And what we can actually do is use our rule for exponents that have the same base. And we can actually just go ahead and subtract these exponents. So 5 minus 2. And we keep the same base. So for 20, we have to take the square root of 9, which is 3, and then minus the square root of 4 squared. Remember that roots and squares and exponent powers are opposite operations, so they cancel each other out. They're inverse operations, leaving you with just the 4. So you have 3 minus 4. 5 to the power of 6. 5 divided by 6 squared. So it's just going to be 5 6 times 5 6. And then you go ahead and multiply straight across. Remember that in fractions, we operate on the numerator and the denominator. 24, we have 3/4 times 1/2 times 8/9. And again, we can write this out as prime factorization, as a set of prime factors. So instead of 4, it's 2 times 2. 1/2 is already prime number, so we just keep it that way. 8/9 is 2 times 2 times 2 divided by 3 times 3. And then we can just cross out common factors that are opposite sides 1 to 1. And then we leave whatever's left. You multiply it. Kevin clipped 3 corners from a square sheet of paper. So 1 corner gone, 2 corner gone, 3 corner gone. Right? Those are the 3 that he clipped. What was the name of the polygon that was being formed? So you want to count the sides that are left after he clips and then name the polygon. 26, evaluate the following expression for A equals 10 and B equals 100. So for A, keeping in mind that when we have variables next to each other, it's actually multiplication. For B, A minus B, so you want to take A, which is A, which is 10, and subtract 100. So you should have a negative difference. And for C, you're going to have A, which is 10, divided by 100. And then we simplify, if we can. 27a, find the dimension of the figure at the right. Dimensions are in yards. All the angles are right angles, which tells us that when we have opposite sides, such as this one here, we know that this x value is actually equivalent to the opposite end. If we were to make a little invisible line connecting there and there, that actually tells us 10 and 10. So for the first one, we have x. That first missing side is 10 plus 10. And then for the other missing side, we have this little sliver here plus this section here is equivalent to 25. So what we have is we have y plus 20. And again, we get the 20 from this value here. Put there. This is our y value. That's going to equal 25. So you solve for x, you solve for y, and then you add the other 4 values for this polygon. B is asking, how did you find the missing measures of 2 sides of the figure? Well, you set up these 2 equations and then you solve for them. You use opposite sides to help you solve for those missing sides. 28, find equivalent fractions for 1/4 and 1/6 that have denominators of 12, and then you're going to have to add them. So for the 1/4, you make a fraction out of 12. For 1/6, you also make a fraction out of 12. You use your equivalent fractions strategies. So you're going to multiply the numerator and the denominator by a common factor. There are going to be different numbers that you're going to multiply though. And once you have those two, you simply take them and you're going to add them. So that fraction plus that fraction, and simplify if you can. 29, segment AC divides the rectangle ABCD into 2 congruent triangles. Angle ADC corresponds to CBA. Name 2 more pairs of corresponding angles. Corresponding meaning that they're in the same location, basically in the same place, just in a different location, I guess. So angle ADC, which is this angle, corresponds to CBA. Name 2 more pairs of corresponding angles. So you notice that this angle ACB is going to correspond, because if we flip the triangle upside down, you'll notice that this corner actually matches up with this corner here, and you want to have to name that angle as well. You're going to have to use 3 because angle A could be referring to this one or that one. So you're going to have to use 3 of the letters for the triangle. Keep in mind, though, that in this angle, C would go in the middle. See, CBA meant B in the middle here. ADC meant D in the middle there. So make sure that you name the corresponding angles, and this one is actually going to correspond or match up with this angle there. 30, arrange these numbers in order from least to greatest. We put 0 in the middle. We put all the negative numbers on the left. Keep in mind that when we have negative numbers, the smaller their absolute value, the more value that they have. So if it's actually like -4, that's less than -1. And then once you pass the 0 mark, then obviously, the numbers get bigger. The ordered numbers in the answer to part A form a sequence. What are the next three positive numbers in the sequence? So you have to keep in mind what the sequence is. And it looks like the sequence is that we're adding half every time. So for the next three positive numbers, just add a half, add half, and you add half. All right, your extra credit. We were given three cities here. And each of these cities is actually very, very interesting. So I believe we have Hartford, right? Then we had Portland, and then we had I think it was Los Angeles. Was the other one? Yeah, Los Angeles. And so you know me, I'm a big sports person. So I want you to find a professional team from each city. Now for Hartford, they used to have a hockey team, but they don't anymore. So just find out the name of that hockey team. For Portland, I actually want you to find the name of the soccer team. And then for Los Angeles, I want you to find the name of um, the football team. They actually have a couple now, so either one is fine. That's your extra credit. If you found this useful, please hit like and subscribe for more homework videos that I will be sharing with you on Google Classroom. Thanks for tuning in. Have a good day, and we'll see you later.